So good morning all and welcome back to the session. Friends, in the last session, what we have discussed, we have gone through with the advanced drag optimization techniques, and with respect to those optimization techniques, we especially discussed about subqueries or query decomposition. Okay, so over there, what we have seen. We are going to divide the queries into multiple queries, and then we are going to ask the question with chain of thoughts or independent query in order to have the query decomposition. So that is the stuff we have seen in our previous session. And if I try to mention, so from the advanced track optimization techniques, what we have covered so far, say query transformation. Inside the query transformation, we have seen multiple query rewrite. What else?
Chain of thoughts, query decomposition,
Mm-hmm.
independent query, hide,
Have we
step back
discussed
approach.
hide so far? What
Hide
else?
actually step back approach,
Step back
chain of
approach.
thoughts.
We are going to discuss today step back approach. Okay, so let's discuss about the step back approach. Okay, so these are the things what we have seen so far, and like we are having certain other techniques as well, but let's discuss about the step back approach. So once we are talking about the back approach, what is the actual meaning of step back approach? Just have a look over here. Okay, from where I have started. Let me try to correct it. Okay, so step back approach is something. Uh, say once we have asked a particular question to the large language model, and that particular question is not pretty clear, so we are going to provide certain instructions to the large language model, uh, that if I'm writing the question in this particular way, then you need to convert it into the different way. Like we are going to share certain examples to the large language model how it need to behave. Probably you are able to recall few short learning. What is the meaning of that? Are you able to recall what is few short learning? Can anybody tell me what is few short learning? Anybody? Hmm? So let me try to give the example. So what is being happening? Okay, or let me ask from the chat GPT. Yeah. Okay. So over here, what I can say, this is not the correct way. Share some examples for few short learning. Okay, so we are giving one question to the large language model and the expected output as well. So that is nothing but few short learning. So input output. That is not okay. So this is, you can say, the output, expected output. Okay, so you are giving uh, an input, you are providing an expected output as well, giving an input and expected output as well. So this is nothing but few short learning. And what I can ask over here, uh, can you share the prompt? System prompt I need to ask. I think I have system prompt. PTH. The main intent is over here, like what I want to say. Say, oh, say if you are providing an input, you are providing an expected output as well to the large language model, so that it will be able to train itself onto that particular data. Probably you are able to recall, like once we are going to to train the large language model, okay, based upon certain data. Say if you are willing to have a question and answer agent, then you are going to provide certain question and their answer, and then you provide the question, and then large language model will be able to provide the outcome in that particular way.
So it is part of a multiple question answering, na? Like thousands of question and answers with the help of model is learning. That is part of research learning, correct, sir?
uh then that is not few short learning. Okay, we can, few short learning means you are uh, going to provide 10 to 50, 20. It depends upon like the data that you are handling. Say if you are having less amount of data, then 10 to 15 questions are fine in order to provide the instruction to the large language model. Guys, please go on mute.
Okay, model learning with the help of small some examples.
Yes, few short learning, that's why it is called few short learning. Okay, so over here we are going to utilize that particular approach basically, and the main intent over here, I just want to provide you the information, or I just want to uh, give the information that this particular stuff we have discussed in our previous sessions, so step back approach, if I'm going to say, if the question what is being asked by the user, that is not pretty clear, so I'm going to instruct the large language model that you need to convert it into a more refined way. Okay, so question is step back basically, or some it can be, you can say, related to uh, the query rewrite. Okay, but query rewrite over there, we what we are instructing the large language model in such a way that you need to uh, generate the new question based upon the the question that is asked by the user. But over here we are providing the instruction to the large language model that you need to convert the question in this particular way. We are instructing the large language model now. Okay. Over there inside the query rewriting, the large language model is going to work on to the instruction that you need to convert it into the different way. But how the large language model need to convert, over here we are providing those instructions with the help of few short learning. Fine so far? An example, what I can say, so the input is say uh, could you put the member of the police perform the lawful arrest, and I'm giving an output on top of this as well. Say, and now you will be having the clarity why we are saying this a step back approach. What can the member of the police do? Okay, so if you are able to see, the question is more generalized over here, is it? Over here we are asking like the could the member of the police perform the lawful arrest, but over here we are asking what are the what the police what the member of police is going to perform, correct? Take another example. Input is uh,
You mean to say it will convert your query into more generalized way?
yes, we are converting the query into
But
the more generalized way.
in that case, suppose if we are pointing towards particular content in our query, maybe
Hmm.
that part will be vanished. Like
Huh.
in this query, we are forcing more toward this lawful arrest, right? But in the generalized way, it has removed that line.
Yes, that is perfectly fine.
So maybe our output can change in that case, no?
Yes, definitely it can be changed, but it will probably like over here we are not able to get the good accuracy output, or user is not pretty clear what he is willing to ask.
I was thinking about any the use case, like how it will.
Okay, how it can be. Okay, you can take it over here as well. So over here, say you the user is willing to have the classification of the given, you can say, input. Say the user is providing the positive, the comment is positive or negative. Once we will be going through with the fine tuning approach, that is nothing but the another, you can say, optimization technique. What we can have, fine tuning is nothing but like either you can go with rag or the fine tuning. So fine tuning where we are going to change the weights of the large language model. Inside the rag we are not changing the weights. So say the large language model, say I'm going to utilize the large language model for sentiment analysis, but whatever I'm feeding, the large language model is not having that particular data, and the accuracy of the outcome is not correct. So what I can do, I can have the labeled data. This is known as a labeled data basically. Okay, input is given, output is given. So I can give certain labeled data in order to train the large language model. Okay, and then I will be able to get the correct output. So this is a way, like either you can do the labeling kind of stuff. Say you can do the sentiment analysis. If like these are the things, then you need to have positive, negative, or any other sentiment. So you can utilize in that particular way as well, like you are providing certain prompts and then asking the large language model to provide the outcome in that particular specific way. Okay, so over here, another use case, another use case, you are asking the question. Now over here, what I'm doing, going to do, I'm going to perform, I'm expecting the output from this, so output in terms of the refined question, but I can expect the output in terms of the answer as well. Okay,
Hmm.
so over here you can mention, say yes, the police can perform the lawful arrest. Okay, so then the large language model will be trained in such a way, and it will be able to provide the outcome in that particular direction. So depends upon use case to use case. But yes, the large language model is going to take these particular instructions, and it will depend, like either is it going to it is going to fulfill your requirement or not. You need to check it thoroughly, right? But this is an approach where we can tune to our question in more, you can say, generalized question, and that will be given to the large language model in order to have the broader outcome, not the specific to or restricted to this particular one where the user is not having the clarity. Okay, and because of that only, we are not able to get the correct output or optimized output. Our main intent is to optimize the output, whatever we are getting. Correct?
Hmm. Maybe we can check with the more examples.
Yes, 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 yes. Okay, so Jan, uh, Jenny was born uh, in what country? Okay, and say I'm expecting output. What is Jan personal history? Okay, so we are going to convert the question into a more generalized question basically. Yeah. So over here, we are going to utilize this step back approach, and then we will be able to get the outcome. And the approach, what it will be: query, then step back approach, or you can say the new query. Then new query will be going to get the data. Okay, vector search will happen. New query, vector search. Okay, and then it will be given to LLM along with this particular query. Okay, so so over here you can take what is Jan personal history. So this particular stuff will be covering this particular question. Over here, what we are doing, we are having the generalized, you can say, question, and once we are going to perform the generalized search, it will fetch all the information about Jenny, say personal information, personal history, that it will include this particular stuff as well, and then we will give it to the large language model in order to have the refined output, right? Refined output means it will provide more information, and you can take it in this particular way. The user is willing to have the Jenny information, like where she was born, but along with this particular information, the user is willing to have certain more information, but he has not mentioned it over here thoroughly. So the large language model first convert it into the generalized question, then generalized output is given to the large language model in order to provide the final output. Okay, so this is the step back approach, and short learning is utilized over here in order to perform that particular task. And let's see how we will be going to have the implementation of it practically. Okay, so what I can do, I can have a new notebook, and then I will do certain copy and paste. So these particular things will remain same, and copy, and let me rename it to advanced rag langchain 6, not 5 6. So the execution has been done. I will copy the API as well, API key as well, and then what I will do, I will load certain data. Okay, that is perfectly fine. The loading is done. Now what I will do, I will do embedding text, chunking, embedding, and uh, moving this particular data into vector store. Is it the complete one? Let me copy from here. Okay, so this particular portion is the same what we have seen in our previous session, and I will define the large language model as well. So that is perfectly fine. Now what I will do, I will define the prompt. I will define the prompt, that is a few short examples. Few short examples. Okay, so over here I just need to use from LangChain underscore core dot prompts. Mhm. Prompts import few short template. Okay, I'm going to import few short message prompt template. That is perfectly fine. Now I'm having the examples, say examples, and I will provide those particular examples. And I will try to copy and paste these particular examples. This is example 1. This is example 2. Okay, so these are the examples what I'm going to have. And what is the issue over here? Output, what is the gen is? So these are the examples what I will have. Uh, these are nothing but the few short examples. Basically, I'm giving an input and expecting an output as well. And that is nothing but more generalized output based upon the given input. Okay, so this is perfectly fine. What I will do, I will have a prompt based upon this. Say example prompt, and then what I will do, chat prompt template dot from message, and now I will have what, I will have, say human message, and then what it will be the input basically, human, and then I will be having the AI message, AI message, and it will be the output. Okay, so human message and then AI message, and this is the time to close this. And now what I can have, this is say few short messages. Uh, these are the examples basically. Then I'm having the example prompt. Now what I will have the few short prompt. Few short prompt. I will create a prompt over here, and what I will do, uh, I will use a few short chat message prompt template, and then what I will do, I will use the examples and example prompt over here. So example prompt equal to example prompt. Let me copy, equal to example prompt, and then examples equal to examples. This is few short prompt what I'm having. PROMPT. It has been defined over here. Okay, this is not executed yet. Just have a look. So I need to execute it, and then it will work. So I have defined few short prompt. Then what I will do, I will have the prompt basically for this particular use case. So prompt, what it will be, I will use chat prompt template dot from messages, and now I will start defining the prompt. Okay, and it will be like this, and say system, and over here I can mention you are an expert at the say world knowledge. Your task is to step back and paraphrase a question to a more generic step back question, which is easier to answer. Here are some examples. Examples. And examples are what? A few short examples, and I will give few short prompt over here, and then new question. Human, and then I will have the question. Okay, so just have a look what we have done so far. I have given certain examples. Okay, based upon these particular examples, I have created the example prompt. Okay, so this is nothing but like I'm having the human message input is given and AI message output is given, and it has been captured from here. Input is over here, output is here. Okay, so these examples are utilized in order to create the example prompt. Then this example prompt and examples are utilized inside the few short prompt. I just need to have the few short prompt, what I am going to pass to the prompt basically, uh, in order to provide the instruction. Over here I'm providing the instructions to the large language model that you need to use few short prompt in order to provide, in order to generate the question. Okay, in order to generate the new question basically. Okay, so this is the system message, these are the few short prompt, and this is the, you can say, human message. It will come over here, and then based upon that, like the new question, new output will be generated. These are the instructions in order to get the new question or new generic questions, a question from the large language model. Now, just have a look over here what I can do. So I'm having the prompt. I can pass this prompt to the large language model. First, I will define the chain, okay, and then execute that particular chain in order to get the more generalized question. Okay, so generate step back query. So what I will do, I will have this particular prompt. I will give it to LLM, and then I will have string output parser. Okay, that is perfectly fine. I am having a question, say, I can give a question over here, and question is, say, what is the task decomposition for LLM agents? So it will convert it into the more generalized question. Just have a look how it will work. So generate step back query dot invoke, and I will pass this particular question over here, and it will be passed in this particular way, key and value pair, and I just need to create a dictionary over here. Okay, and it will be, say, uh, new question, what I can say. What is happened? Name prompt is not defined. Have we done? We haven't executed this. Uh, human. Comma is missing. Still, guys, are you able to see any error? Few short prompt, then human. It's looking fine. This is the system prompt. Few short prompt.
I think comma after human in place of
Hmm.
semicolon.
Yes. This is a good catch. Hmm. Okay. Now prompt is there. Okay. And let me try to print the question. New question basically. Okay. So just have a look over here. What is the task decomposition for LLM agent? Okay. And the generalized question is, how do LLM agent decompose task into the smaller steps? Correct. So it is a little bit, you can say, more generalized question, and it is based upon the instructions what we have given. Think for a minute and ask if you are having any doubt, guys. Think for a minute. It's really very simple. You will be able to understand, but think for a minute and ask. Is it fine with everyone up to so far? Javed, Vikas, Lakshmi, Nikhil, Yogendra,
Yes,
Raj.
sir. Yes, sir.
Yes, yes, yes.
Perfect, huh? Is it? Say yes or no, guys.
Yes, sir.
Yes,
Yes, sir.
yes.
Okay,
Yes, yes.
perfect. Perfect. Huh?
It will convert our question to generic
Yeah,
questions
this is
only.
the generic one. Huh? This is the generic one. Huh? Or you can mention over here, say, print question and say new generic question. We can utilize new line con.
So in which scenario these actually this optimization technique will be using? Because I think this technique will hallucinate output. There will be more chance to hallucination.
Okay. So what we will do, we will pass the original output, okay, along with the new output. I will show you, like then it will be more correct output. So say if you are trying to ask the question, if you want to fetch the document based upon the older question, say you, let me mention over here. Say we are having this particular query and say we got 4 dogs, okay, then we are having new query and again we got say 4 dogs, right? Now these particular 8 dogs, what I will do, I got your point, and Javed, I try to think onto the Javed input as well. So say if we are going to provide these 4 dogs to the large language model, so it will be completely based upon the new query and we will be able to get, probably we will be getting uh, uh, hallucinated output. So what I will do, I will give these both to the large language model in order to get the more correct output. Will it be fine with you all?
Yes, sir.
Javed, is it shorting your issue?
Can you explain again? I'm just in a little bit in doubt, like why we're giving these two documents.
Query, this is the original query. Okay, I will be fetching the documents based upon the original one. Then I will be fetching the documents based upon the new query as well. Say
Okay.
this is the original query, this is the new query. I will be fetching the documents based upon both of these two, and then I will provide these for 8 docs to the large language model in order to provide me the output. Correct?
Okay. Okay.
So then
Yes.
it will be more refined.
Yes. Yes.
Okay, so I will try to mold the prompt in that particular way. New, so this is a original question, and I will have question over here. Okay, so just have a look. This is the original question. Okay, what is the task decomposition for LLM? And this is the new generic question, which is generated by the large language model. Perfectly fine. Now, what I will do, I will have another template. Okay, I will try to define another prompt basically, which is going to utilize these two questions in order to get the output. So just have a look over here, the response, prompt, and template. And I can mention the template over here. Say you are an expert of world knowledge. I am going to ask I'm going to ask you a question. Your response should be comprehensive and not contradictory or contradicted with the following context if they are not relevant. Otherwise, ignore them if they are not relevant. Then what I can have, uh, hmm, normal context. I'm trying to uh, thinking and step back context. So these will be two contexts what I will be having. And then original question. Okay, so I have defined a template over here, like you are the expert of world knowledge, and we are going to ask a question. If your response should be comprehensive, not the contradictory with the following context. Okay, so I'm going to have two context, normal context and step back context. Basically, normal is the initial one, and step back, which is the new context, basically based upon this particular question. Okay, say and if they are not relevant. Okay, so contradicted with the following context if they are not relevant. Otherwise, ignore them if they are not relevant. Okay, so if these particular things are not relevant, then I have mentioned that you need to ignore it. So if this and this one contexts are not relevant, then uh, it need to ignore it. So this is, say, the prompt what response template, and what I can have prompt, I can create the prompt as well. The response and the prompt, and it will be chat prompt template dot from template. And I can give this particular template over here. So I'm having the prompt. What I say prompt? Okay, I have not executed this. Okay, so I'm having this particular prompt. Okay, now what I need to do, I just need to have the normal context and the original context, step back context, and along with the prompt I will give it to the large language model, and then I will be able to get the output. So so I am going to define a chain over here, and it will be, the chain will be looking like this. Chain is, say, I just need to have first, say, normal context, and if I just need to have the normal context, what I need to do, normal context, so normal context, what it will be, mm, okay, runnable lambda, and if I pass x, then x of question, x of question, and I will give it to what, I will give it to retriever, so I will be having the normal context. Okay, so it will give me the normal context, and this is, you can say, literally simple. I'm just providing the question to the retriever. Okay, and if like I'm having x, say, uh, it can be anything. So if I'm having x of question, I'm going to provide to the retriever, and I will be able to get the normal context. In the step back context, for the step back context, I am going to perform the same approach. Okay, so this is this step back context, and what I will do, this is the step back context. Step back context is going to utilize what, it is going to utilize, let me have the execution of this, generate step back query. This particular stuff is going to be utilized in order to get the step back context, right? Generate step back query, and it will, over here, this you need to check, this is nothing but a chain I have defined, and it is going to take prompt llm, and it will provide me the query, it will provide me the question basically. Okay, so that is perfectly fine, and this particular question as well, I am going to provide to the retriever. Fine so far? Is there any issue?
Okay, sir.
Okay, then I will be having the question, original question, and I will utilize this particular stuff, lambda x of x dot question, x question, and that is fine. And there is no need to have this particular bracket as well, and comma, and then what I will have a particular prompt, response prompt. So I'm having normal context, step back context, and question. What I will do, I will give it to the prompt. Then prompt will be given to the LLM. Okay, and from LLM, it will be given to what? String output parser. Okay, and this is nothing but a chain what I'm having now. Okay, and this chain is containing each and everything. Normal things are looking fine. Let me try to execute it. And chain dot invoke, and I can have the question over here in dictionary format, and I can say this is nothing but answer, chain dot invoke, not hyphen, and let me print the answer as well now. Okay, just have a look over here now. So we are able to get the answer now. Correct? Is it fine with everyone? Are you able to get the approach, guys? Hmm?
Yes, sir.
All
If
of you, is it fine? Hmm.
Yeah. Yes, sir.
Any confusion, any doubt up to so far? Lakshmi, Javed,
That's
Can
Vikas.
you
fine.
show the answer? Can you show the answer?
Yeah,
So this will be very elaborative answer based on your generic question.
generic and the normal. I have used the both of these two contexts. And if you are willing to get the outcome based upon the step back, you just need to remove this particular part. It is included based upon your inputs only. Okay, the normal context and this particular piece you can remove, and then you will be able to get the outcome based upon the new question only. Step back question only. Correct.
Okay, so the final answer will be conclusive based on new query and your step back query
Ha
also.
ha 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 ha.
Okay.
Let me try to mention it over here as well. Step back context.
in this scenario, both like new query, step back query, and original query both are passed to provide the answer. And if we also mentioned the condition, if step back query is hallucinating the output, then it can be ignored. Correct, Nasir?
Yeah, we have mentioned the prompt in such a way that if the normal context and the step back context is not relevant, then it is going to avoid it. Okay, you can mention in this particular way. You have given the large language model these particular instruction. If this normal context and step back context along with the question that is given with the prompt to the large language model, you have mentioned these particular thing inside the response prompt, right?
Right,
Correct.
sir.
Okay,
Okay, sir.
perfectly fine now. Javed, is it fine now?
Yes, yes.
Okay, So this is nothing but the the decomposition. Sorry, a step back approach, and we have seen it. Now, another one is what? Hide. Okay, so from the advanced RAG optimization perspective, we have seen multiple query rewrite, RAG fusion, query decomposition, okay, step back approach. The next one is hide. That is nothing but hypothetical documentation. Hide. Okay. So, what is being happening inside the hide? Let me try to. So hide. So inside the hide, the user is going to ask the question. User asks the question. Then it will be given to the large language model. Okay, and we will be getting the hallucinated output. Hallucinated output. This particular output is utilized in order to have the vector search. Okay, and then whatever we are getting, okay, these particular things will be given to the large language model in order to provide the output. So, so previously, what we were doing, we were the user query is not directly, you can say, given uh, to the large language model. So over here we were trying to generate the new query, but over here what we are going to do, we are going to ask the output. We are not going to ask the query over here, but we are going to ask like what is the output on top of this particular query from the large language model, and whatever we are going to get, which that particular stuff is utilized in order to do the search onto the vector db, and then the output is given to the large language model in order to have the final output. Okay, so this is the stuff which is nothing but hide. Are you able to get it?
So it will check in the two steps. I mean, the LLM will be using two times over here.
LLM is will
But
be
this vector
utilized.
search is happening in the first step also, no? When we are getting hallucinated output.
Vectors. No, 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 no. This is going to utilize the LLM intelligence.
Okay, so okay means we are not using any this
Database.
similarity
Database.
database.
Mhm,
Okay.
mhm, mhm. Okay,
So
so
the first
you
step is directly check in the LLM, then it will go for the vector search.
correct.
Okay.
Okay, this is really implementation is very simple. Okay, only we just need to understand this particular flow. Implementation is very simple for this. So
So
let's
basically, whatever the RAG system we are using, so that we have to modify little bit for this case.
yes.
Okay.
So what we are having. Let me try to copy these particular things. Okay, do the execution, copy the API key, do the execution for this as well. I just want to have the documents. I am going to load the documents. Now I will perform splitting, embedding, and moving these particular docs to the vector store. So these particular steps are the same what we have seen so far, and I will define the large language model as well. Okay, so I'm going to utilize the GPT-5 Nano, and now uh, we will try to have the implementation of HIDA. So whatever we have done so far, these are the common steps in all the in all of the RAG optimization techniques, especially talking about the query transformation. Okay, so what I will do in order to have the implementation of hide, I will have a template. Say template, and template is say please write a scientific paper to answer the question. Answer the question. You will be having the question, and then you will be having the passage, and that is perfectly fine. Okay, so this is a template basically, and over here I'm going to ask the answer to the large language model. It is not like say I'm trying to get a new question or new query. You can refer the previous stuff. Okay, so over here you are an expert. Task is to step back and paraphrase a question to more generic step back question. Over here the outcome what we are expecting, the question only, but over here we are expecting a passage or expecting an output from the large language model based upon the given question. Okay, so let me define the hide prompt underscore say hide, or say hide prompt. Let me mention hide prompt, and it will be say chat from template dot from template, and I can pass this particular template. Pretty simple. And then what I will have say uh, output basically. Okay, intermediate output. So what I will do, uh, generate output, and the hide prompt will be given to generate output chain, what I can say, chain hide prompt, it will be given to LLM, and then string output parser. String output parser, I need to define a question. Okay, and then I will be able to get the outcome based upon that particular question. Okay, so just have a look over here. Question, I just need to define the question over here, and what it can be. I can utilize this particular question. Hide prompt is not defined. Let me mention the question as well. So I have not executed this. This is the question, and if I invoke this chain dot invoke and I pass this particular question as a dictionary, and I will be able to get the output. Huh? It is going to, okay, just have a look over here. So it has given me this particular output. Huh? Title decomposition of verbal framework. Huh? It has given me this particular output, but this is not based upon the document. Huh? Correct? Is it?
Correct, correct.
And what I can say, I can have say retrieved as a document. Huh? Okay, this is a document basically what I got from the large language model. Huh? Correct? Document. And what I will do, I will utilize this particular document. So that this is perfectly fine. Like one step is over, and if we are talking about this particular diagram, we are having this particular hallucinated output. We were having the user query, and we asked this particular user query to the large language model, and we got the hallucinated output. Now what we will do, we will define our template. Okay, so now it will be rag basically. Okay, and say template, what it will be, and answer the following question based upon the context. Context, and I'm going to say have the context and say question. Okay, so this particular retrieve document will be utilized as a context uh, over here. Just have a look. Now what I will do, I will define a prompt over here. Let me have the execution. So prompt is chat prompt template dot from template, and I will pass this particular template over here. So I'm having a prompt that is perfectly fine, and final rag chain, what it will be, it will be going to utilize this particular prompt, and then I am going to have this to LLM, and then string output parser. Okay, something we are okay, okay. So we are missing something. So we got the output. What we have missed. So question. This is perfectly fine. I'm not. Probably I have missed where we need to utilize the retrievers. I just need to define the retriever. Retriever is not utilized so far. So I got this documents based upon. So before this, what I need to do? So I just need to have say. Hmm, just a minute. LLM hallucinated output. So that is nothing but a retrieved document. Generate documents. These will be given to the retriever. Okay. So we generate output chain that is we are having hide prompt. I'm confused a little bit. We are having hide prompt, that is perfectly fine. Now generate output chain, generate output. Let me generate output for retrieval. Generate output for retrieval, that is perfectly fine. Now we are having question, and what I can say, generate output retrieval, that is perfectly fine. I will be getting the new output over here. Now what I will do, based upon this, I will be having say retrieval. I will be having the retrieval chain, and it will be going to take what? It will be going to take this retrieval, generate output retrieval, this particular stuff. It will be given to what? Retriever, retriever, then retrieved docs. From this particular retriever, will be retrieving the docs. So I just need to invoke this particular chain based upon this particular question, and then retrieve docs. Okay, documents are coming, that is perfectly fine. Final chain dot invoke, and I will pass the context. Context will be retrieved docs, and question will be question. Guys, are you able to understand what I have done over here? And this will be say answer. Are you able to understand what I have done over here?
No, sir. Please repeat once these two, three steps.
Okay. So let's remove this one. So what we have done, uh, we have defined this particular template initially, hide template, that you need to generate a response, response based upon the given question. So please write a specific paper to answer the question and then passage. So we are just passing a particular question, okay, to the large language model in order to get the output. So we are having this particular chain, generate output retrieval. So we are passing this particular prompt what we are having to the LLM, and then we are parsing it. So the question is this one, and once we are going to invoke this particular chain, generate output chain. So we are able to get the output from the large language model, but based upon this particular question. Okay, we are able to get this particular output. Fine so far. We are having a prompt, a question, and it is given to the large language model, and then we are able to get the output. Fine.
Yes.
Okay,
Yes.
perfect. So we are able to get the output. Now, this particular output, what we got, that will be utilized, that will be given to the retriever. Previously, we were giving the question, okay, to the retriever in order to get the output. But over here, we are passing this particular document, what we got over here, to the retriever, right? In order to get the output. So
Okay.
we have passed this particular output from the large language model instead of the question. So previously, in the previous example, if you are able to see, we are passing the question to the retriever, like
To
question
the
is
retrieval.
given, yeah. But over here, generate output retrieval is given to retriever in order to get the output, in order to get the docs. So this is a chain, like I will be going to have this particular stuff, generate output retrieval as an input to the retriever, and it will provide me the documents. So retrieve documents I will get once I'm going to invoke this particular chain. So I have given this particular question. Okay, it will first, you can say, generate output retrieval will be executed. So if we are going to generate output retrieval, so generate output retrieval is this. So it is going to do what? It is going to invoke, and it is going to have the question we are passing. Okay, so generate output retrieval is going to have this hide. It is going to take hide from uh, that we have defined over here. It will give it to the LLM, and then it will pass the output. So we will be getting this particular stuff will be given to the retriever, and then we will be getting the documents. And just have a look, these particular documents we got. Retrieve docs. So say document metadata, if you are able to see. So we got the four document 1, document 2, and document 3 and document 4. Okay, so these four documents are there. Now these four documents will be given to the large language model as a context to provide the output. So what we have defined another template, like ask the following question based upon the context. So context we need to give. Okay, what is it? And then we just need to pass the question over here. So then what I have defined the final chain. It is going to take the prompt, and then LLM and string output parser. So final answer, what it will be, I'm going to invoke this particular final chain, and I will provide the context is what? Retrieved documents. And question is what? The initial question. So once I'm going to give this, I will be able to get this particular output. Correct? Is it fine with everyone? Is it fine with
Yes.
everyone? Javed, Nikhil, Lakshmi, Vikas, Yogendra.
Yes, sir.
Okay, so why I was confused basically. So I got this particular output, and I haven't performed the vector search. So that particular portion I missed, and I just start defining this LLM portion, and I was trying to get the output. But then I recall that I haven't done the vector search. If the vector search is not done, then you will not be able to get the outcome from the RAG. It will be the output from the large language model. Correct? If you are getting the hallucinated output, and again you are providing that hallucinated output to the large language model, then you will get more hallucinated output. Correct? If you miss this particular step, say, then what will happen? You will get more hallucinated output. Query is there, it is given to LLM. LLM is going to provide the output. Then that particular output, if you are going to provide the LLM, then you will be getting the more hallucinated output. Is it? Are you able to understand? So
Correct, sir.
I
Correct, sir.
I missed this particular part. Okay, vector search. So, but I recalled it and then I defined this particular piece. Correct? Because
This LLM only approaches, that is purely LLM output, and then the output. Can you show the output? This LLM only approaches the first paragraph, that is through LLM in the
I,
output.
I didn't get your query properly, Javed.
In the answer, we have two things. One is LLM only approaches. Then is second one is LLM plus P external planet approach, right?
Huh. First one is you can say LLM is going to provide the output based upon the query, and
Which
that
is
is
being hallucinated. The
this
second
is the
one is after
hallucinated
the.
output. This is the hallucinated output. RAG documents are not utilized over here.
No, I'm talking about the final answer. We are getting
Final
two
answer,
paragraphs.
final answer. Over here, I have given the context as retrieved document, and retrieved documents are coming from the RAG.
Yes.
Okay, so these are the retrieved documents. So I gave the hallucinated output to the retriever to fetch these particular docs.
Okay.
Okay, this is the hallucinated output, generate output retrieval. This is the hallucinated output from the large language model
Okay. So the
based upon.
final answer which we are getting, that is completely through vector search.
Yes, yes, yes. That is from the vector search.
Okay.
Okay. So, and why it is refined one? Because over here the search has happened based upon this particular query, not with respect to the initial query.
Yes. Yes.
Okay. So we are able to get more, you can say, refined docs based upon the broader search, what I can say. And once the broader search is there, I will be able to get the more refined output. So that is nothing but hide.
So
Fine.
here we are not giving any specific document. It is retrieving the document by its own, and that is going to give to the LLM. So doesn't it going to take more number of tokens
Yeah, definitely it will consume more tokens.
because we don't have any control on that, right?
You can have control, like you can restrict the LLM output, say 200 tokens, 300 tokens.
Okay.
You can mention in the prompt only. Yeah?
Mhm.
Correct.
One
But
more
whatever.
question is okay.
Hmm.
Maybe it is related, not related to the subject, but if we are using these LLMs in our organization,
Mm-hmm.
so what security concern we have to take care?
Uh, so basically, there are, you can say, different things. If you are going to expose your data to the large language
Mhm.
model, definitely it is going to train, it is going to utilize that particular data.
Of course.
Okay, so what you can do, you can have a server. Okay, and on that particular server you can deploy that particular model, and you can call that particular server through API. At this moment we are calling the OpenAI API, and the data is going to that particular server, and then it is going to have the analysis of this particular data and then providing us the output. Okay, so call is going on to there, the data along with the data. So if you can configure this particular server within your organization, then you can restrict uh, exposing of your data to the external servers, right?
Mhm.
Making sense?
But that server will also be exposed to internet, isn't it?
No, no, no. Why it will be exposed to the internet? You are providing your data to the to that particular server. Okay, and that model, say over here, say GPT-5 Nano is being utilized, right? So
Mm.
that particular model is going to work on top of your data, and yes, it can train itself on that server only, but
So we have to restrict it to not train in word knowledge, then internal knowledge only.
no, no, you that restrictions can't be done because LLMs are designed in such a way. But and you although you want that LLMs should be trained, but that training with be must be restricted to your organization. It is not like the data. You can think in this particular. Let me provide.
So Ashok,
Say,
in that case, we need a server, then we have to install that LLM in our
and
server. Then,
that's what your organization has done, Javed.
yeah, yeah.
Okay,
So
so
after that, it's up to organization whether they want to explore the external world or not,
yes.
whether they want to train internally or
Huh.
externally.
So what organizations are doing, say servers are nothing but the machines basically. Okay, and these are placed say somewhere in or in your organization, or it might be possible these are placed onto the AWS. Huh? Say these are placed onto the AWS. Huh? But and over here you have configured your LLM. Huh? Okay, so this is your proprietary. Okay, it is not say AWS is going to utilize this particular large language model uh, in order to infer the queries from the different users. Say over here HR is there, R&D is there. Okay, and say you are from the R&D and you are going to utilize this particular large language model. Okay, so you will be your team will be the whole soul, you can say, owner of this particular configured LLM, and you are going to utilize this particular server only, and whatever the data you are going to share to this particular large language model, it will not be exposed to the another server or onto the internet, right? It will be limited to this particular server only, although trainings and all keep on going. Okay, LLM will try to memorize the keywords that you are going to ask, but that will be limited to your server only. Okay, now what is happening in our case? Okay, what is happening in our case? We are using OpenAI, okay, models, and these are uh, these are accessible to all. Okay, now I am asking the question to this particular model, and another one is also, say I'm from, say, one organization, another person of from second organization, then we are having thousands of people who are going to ask the question. So LLM is going to get the inputs from all of these particular persons, and say person one is say from say Nokia, another person say from the Huawei. So both of these two persons are going to ask, and say one similar question is there which is asked by the Nokia, and then it has provided certain data to the large language model that this is the thing, these are the things in order to, or he has uploaded or shared certain documents. Now the another person, say from Huawei, he has not uploaded his document, but he has asked the same question. Now as the LLM is trained onto the Nokia's data, so it will provide the information with respect to the Nokia, and over here the information has been, you can say, shared throughout the world. Correct. But in this particular case, the complete data is limited to server one. You can have server or a bunch of multiple servers which will be acting to solve your queries. Okay, if an LLM is coming, then LLM will be configured, say LLM2 will be configured over here, but that will be limited to your organization only. Making sense? Are you able to
Yes,
get?
yes. Yeah, yeah.
And this is
Yes,
the
yes.
practice with like which all the organizations are doing, and they are saying that you need to utilize these particular large language models. And over here, if you are able to see my screen, and platform.openai, let me open it. And cost, basically pricing. Mhm. So over here, if you are able to see, the large language models are keep on coming. Okay, these particular models are keep on coming. Say your organization is having access to say 5.3 codecs, but there are certain you can say variants. 5.3 is the latest one. Say your organization is having 5.1 chat latest, but now the OpenAI has released this particular version. Okay, so in your organization, you will not be able to have it until unless it is not enabled for you. It is not moved onto your server. Okay, although it is there. So there are multiple ways in order to restrict the the data to the large language models. Okay, exposing the data to the large language models, and it is we can say a topic of discussion as well. Like if we are going having these many models, then how to restrict the data. Okay, and in some of the organizations, uh, these particular portals are not enabled. Say you can't ask the question directly to the chat GPT, Gemini, DeepSeek, because if you are going to copy and paste your data, it will memorize your data. Okay, and it might be possible it can be given to the another user. The outcome can be given to the another user. It has happened. Okay, there are multiple examples, and then like people are thinking in this particular approach in order to have the implementation. Correct? Making sense? Is it fine with everyone?
To encode your input also,
Yes.
right? If you are going to give something, you have to encode it.
Encode, can you elaborate more? Like what?
Elaborate more in the sense like if I am giving some data related to some cell IDs of some network.
Mm-hmm.
So instead of cell ID, maybe I can encode it to numbers. I will not expose the latitude, longitude, means geographical locations. Any PI data I will not going
Yeah,
to
you
give.
can you can
Something like that.
like share sample data, dummy data basically. Don't expose the actual data. Correct.
Yes, yes,
Okay.
yes.
Is there
So
any way, so we can, whatever the input we are feeding, we can encrypt it so that it doesn't go to the outside world? I think Manish context in the same way.
so you can write down your own scripts, Python scripts. Uh, then you can create something like decoder. You can uh, in that particular script try to convert, uh, try to change the data, try to change the name. Okay, uh, whatever is there in your data. Say, uh, like take an example of cell IDs. So if cell IDs are there, then write a script to mask these particular cell IDs. What is being happening? Uh, Inside the world, like personal information is not shared. So what we are going to do, we are going to mask the personal information, say name, age, sex, okay, location, uh, of a particular person. So what we used to do, we are going to mask those particular field, like say phone number is there, and then this particular stuff is nothing but masking. So the data is hidden over here, right? So this particular stuff you can utilize to mask your data, or another stuff like you can remove the information which are, you can say, personal or which you can't share. Okay, so you can remove those particular columns as well. So multiple approaches are there. Encoding, you can encode it to different, you can say, format. Say uh, 122 11122 is there, and you can mention AABB. Okay, so that particular encoding stuff you can utilize. So depends upon organization to organization how you are going to avoid exposing your data to the outside world. Multiple things are there.
Is there any particular technique to mask this data?
Yeah, you can write your Python script.
Yeah.
Okay, you can write your Python script like I'm having. Basically, these particular things are not generic. These are specific to the organization, specific to the problem. Okay, and say if you are willing to have the conversion, say 1122 in this particular way, someone may want 1111 and XX, say, okay, right? So you can, these are literally very simple. You just define one approach, and you can have that script, you can change it, and then you can utilize your data.
Okay.
Okay, these are the simple steps that you can do. Okay, you can ask to the chat GPT as well, like I'm having these particular columns, and I just need to mask in this particular way. Share a Python script. So use that Python script, provide the file, input file, execute that, and convert it into the different one, download the newer file, and you can use that particular data.
But if you are asking to the chat GPT, doesn't it it is already having the decoding technique also?
So basically, you're not asking that I am going to convert cell IDs into this particular format. You are asking that I am having certain data, and I just want to encode it into the different format. Share a script. So you are not mentioning like you just need to utilize this particular stuff uh,
Yeah, yeah.
over there inside
Not
the cell
specific to
IDs only.
any. Yeah, yeah. Got it. Thanks.
Okay, so that is the stuff. Anything else that you want to ask?
Can we do it like if we use as external Excel, and in the Excel we do this decoding?
Excel, yeah, you can utilize Excel as well.
I mean to say
In
we
in
can
in
do in
in
that.
in Excel, you can have some formulas, okay, and based upon those
Or
particular
we can use
formulas,
that Excel as an input.
Excel, then you are exposing your Excel.
Hmm. Yeah, yeah. That is the same thing. With
Uh,
expose will happen.
you don't want to expose, so you just uh, try to get the generic code, and you just need to mold that particular code, or there are certain masking tools as well, but at the moment you just need to expose your data to masking tools. Okay, but
Hmm.
uh, like if the masking tool is onto your in your organization, okay, then you can do that particular stuff. And one of my friend who is working in order to have the conversion of this particular data like personal information to the masked data. So Barclay Bank is there, and they are going to have the conversion of their their personal data to the masked data, and they are having huge amount of data. And why they are doing so that that particular data can be exposed to the large language models in order to get certain patterns and overlap, or exposed to the machine learning models and overlap. So, and say the Barclay Bank, who is going to do this particular stuff, he is they guys are uh, having this particular data, and they need to share it with the another team, say who will be going to perform the the analysis on top of that, or provide certain output. So until unless they are not providing that data, they will not be able to do. So what they are doing, they are masking this particular data, and it's a heavy exercise. They are having Spark jobs to do this particular stuff. Huh? So it is not like say you are the only one who is uh, suffering with this particular problem. This problem is there throughout the world, and I have shared one example. Huh? So masking is done so that we are not going to expose the personal information to outside world. Although like that information, the Barclay Bank is going to share that particular data, and they are having contract that it will not be shared. Still, they are performing the masking on top of personal data, right? Are you able to get up?
Yes.
Yes, yes, yes.
Okay. Anything else?
Yeah, all good. All good. Thank you.
Okay, perfect. So, what we have done, we have gone through with the query transformation, and query transformation, from the query transformation perspective, these are the optimization techniques. Moving further, what we are having, that is query routing. Okay, so query routing, this is the second optimization techniques once we are talking about the RAG, and this is of two types. This is of two type: logical. Number one, logical routing. Okay, and second one is semantic routing. Okay, so I just want to share this particular example, and then you will be able to understand like what is being happening inside the logical routing and semantic routing. And from the practical aspect, like we will see in our next week. So say these are the questions, say this is the stuff like show sales data for 2024, what is the refund policy, create a sport ticket. So over here we are having the logical steps. Basically this is nothing but the logical routing. Okay, so this is nothing but logical routing. Once we are talking about the logical routing, so we are having predefined steps. Like if query contains sales, then you just need to move this particular database. If query contains policy, you just need to uh, proceed over here. If the query contains ticket, then call this particular sport API. Yeah. So logical is something like we are having specified pre-built, you can say, logic, and based upon that particular logic we are going to have the execution of that particular query. Okay, But what is happening with respect to the semantic one? So semantic one, it is based upon the similarity search. Semantic routing is based upon the similarity search. Say we are having financial queries, we are having technical support, we are having HR policies, and say we are having how I can how can I claim travel reimbursement. So based upon this particular query, the similarity search will happen, and based upon this, what we are able to see the claim travel reimbursement. So it is something like financial query. So it will be routing to that particular stuff. Inside the logical routing, we are having pre-built logic, but over here it is based upon the similarity search. So you can take it in this particular user query. It is given to the embedding model, vector similarity search comparison, and closest route is selected. Say route 1 is finance, so it will be routed to finance, close route to route 3. So based upon this, like what we are having certain differences based upon the logical routing and semantic routing. uh, Semantic routing, so decision method is over here rule based, it is embedding based. Understanding, so keyword based. Over here keyword based, like we are going to write down the logic basically. And this is meaning based. Flexibility, it is low flexible because this is like we are going to hard code these particular things. And over here we are having the high flexibility. Setup easy. Okay, over here the vector database is required. Maintenance, high maintenance is required. It is having low maintenance. Okay, accuracy lower because like we are having for the complex queries, because we just need to write down the logics. Over here there is no need to have the pre-built logic. We are just going to utilize the similarity search and all in order to get the output. So this will be the second optimization techniques. If we are able to recall, like there are three techniques inside the query, inside the RAG optimization techniques from the retrieval side. Say query transformation, query routing, and query indexing. So we have gone through in detail with query transformation. The second one is query routing, and it is of two types, logical and semantic. And logical, where we are having pre-built, predefined logics. Semantic, where we are going to perform the similarity search and all in order to move a query to a database or to a particular tool. Okay, so that is the second category of optimization. Third one is indexing. Okay, so in next session, friends, we will be going to have the discussion onto the query routing. So that's it for this particular session. Let me stop recording.